Hello, friend. Myself, Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. In this session, we are extending our discussion with respect to exception handling, and we are going to talk about in detail the various keywords that we use during exception handling mechanism. The first one is try block. As we discussed in earlier message, the try block contains code that needs to be monitored for occurrence of exception. And the point is, if exception occurs in try block, then and then only there is a chance of it being handled. Then and then only there is a chance of it being handled. If exception occurs outside the try block, then it cannot be handled. My program will abnormally terminate. Then student may raise a doubt. Then why not put the complete code in try block? No, putting the complete code in try block generates overhead. uh, it's like when a code is in try block, then it actually generates overhead because my system is cautious about those line of code. So if exception occurs in a try block, then there is a chance of it being handled. If exception occurs outside the try block, cannot be handled. Now try block is followed by catch block, which we have seen in our earlier video. Key catch block contains exception handling code, but it can also be followed by finally. Means try can be followed by catch, or try can be followed by finally block, or try followed by catch followed by finally. Now, what is finally we will see. We will next see catch. Now, catch block contain exception handling code. In our example that we saw in the last video, we have written output statement. Now, output statement is generally the message that will be displayed. भाई इससे आपको ये पता चलेगा कि ये वाला catch execute हुआ है. But in real sense, the exception are handled in different manner. Correct? So, for the time being, you just have to understand that catch contain exception handling code. If there exists any error in the try block, it is caught in the catch block and action is taken, and it follows try block. It works like a method. It's like event handling. Try block generates event and catch block is a handler. It works like a method and accept an argument, and the argument is the object that is created when the exception is generated. So it's like if there is divide by zero, then object divide by zero exception, then object of arithmetic exception class is created and thrown from the try block. And we can have multiple catch, each to handle different kinds of exceptions. Now, this is basically general block. We can have try block that can have its own, and then different types of catch block handling different types of exceptions. Throw. This is very interesting. Let me demonstrate this with an example. Detail and explanation. Now, suppose. Now, suppose we have example. Now, suppose we have class A. And in class A, we have public static void main. And then here's I've written SOP hello. And here we have try block. And then we have catch block, which says this catch block handles arithmetic exception. Again, this is end of the main and end of the class. Now, what I see here, if you see the try block, it contains simple output statement. So there won't be any arithmetic exception here because denominator will not be zero because there is no division only. So if you look at this try block, there is no division. So chance of generating arithmetic exception is not there. But suppose still I want this try block to generate arithmetic exception. Now, how this is possible? There is no division. The denominator is not zero. Now, the point is we should understand what happens if there is a division and denominator is zero. If there is a division and denominator is zero, then arithmetic exception takes place. What will happen whenever any exception takes place, for the matter of fact, is first object of the corresponding exception class is created automatically, and that object is thrown from the try block automatically. So that happens automatically. So if there is number format exception, object of number format exception is created implicitly, automatically, and that object is thrown from the try block automatically. Now, like the way I said, these are system defined exceptions, and this happens automatically. Creation happens automatically and throw on happen automatically. But in this block, there is no division. So there won't be any chance of arithmetic exception, but I still want this try block to generate arithmetic exception. So for that, suppose there is division, denominator is zero, object of arithmetic exception will be created. Let me create new arithmetic exception, new arithmetic exception. Now it means, see, the step number one, object is created, and the next step is throw the object. Now that happens automatically here. Here we need to throw the object using throw keyword. So what is throw keyword? Throw is a keyword that is used to throw the exception object explicitly from the try block. Now, you may argue why there is a need for you throwing arithmetic exception here. That's okay. But I want to demonstrate something, that if at all you want to throw an exception explicitly, you can do so using throw. So it should be throw new an object of the class. Now, ideally, this throw is used to throw user-defined exception, because if the exception is of type system defined, the object is automatically created and thrown. But if the exception is of type user defined, then the object is not automatically created and it is not automatically thrown. It must be created using new and the exception name, and must be thrown explicitly using throw keyword. So throw is basically used to throw keyword, throw exception object explicitly, predominantly used for throwing user defined exception. Let us see in detail. Go back to the PPT. Throw keyword. For built-in exception on occurrence, the object is automatically created and thrown. For user-defined exception, the object is explicitly created and thrown using throw keyword. So if I have my own exception class named as my exception here, and I want to pass an argument invalid number, then I may throw that throw new my exception invalid number. So where my exception is a user-defined exception. So basically, throw is used to explicitly throw the exception object. Throws. Now, throws is very interesting. We'll go back to our example. Now, this is the example that we have taken. Suppose we have only two catch. Okay, have a look. Simple code, ABC. A buffer reader use care. We have read the value of A, we have read the value of B. C will be A by B. Correct? C is A by B result. And we have only two catch. Now, suppose we have only two catch. Now, we have only two catch here. So this is my main and this is my class. Now, the point is, if there is an IO exception, it will be handled because we have an IO exception catch. If there is number format exception, it will be handled. But if there is arithmetic exception, then we don't have catch and my program will abnormally terminate. But the point is here, now catch is, okay, arithmetic exception is checked, is an unchecked type of exception. Now what happens is, there are two types of exception, checked and unchecked. Now in this example, my main is capable of generating arithmetic exception, but it is not handling it. Means the code provided in the try block can generate arithmetic exception if denominator B turns out to be 0, but we are not providing catch for it. The system will allow it to compile, but if there is a problem, program will abnormally terminate. But now, suppose in my class there is a class, there is some checked exception problem like interrupted exception. Now, suppose I'm using, suppose I am asking for some resource, and it causes an interrupt. So in this try block, suppose there is interrupted exception. Now, we are not having catch for interrupted exception. So interrupted exception is a checked type of exception. Means what? If your code is capable of generating interrupted exception and you are not providing it in catch, your program will not compile unless and until you have to specify this here using throws. It is not throw, it is throws. Throws interrupted exception. It simply means that, see, if we have any function and next to function definition, if we have throws an exception name, it simply means that this function is capable of generating this particular exception, but it is not handling it. It means that here in our case, main is capable of generating interrupted exception and main is not handling interrupted exception. Now main is a checked type of exception, so you have to include it in throws list. It's like my function is declaring I am function main, I am capable of generating interrupted exception, but I'm not handling it. See, if there is a catch for interrupted exception, you don't have to write throws interrupted exception. If it is check type of exception, you must write if there is no catch. If it is unchecked type, just arithmetic exception, it is generating, capable of generating, but not handling. But it will be allowed to compile. There is no compulsion for you to write in throws list. Even if you write it is okay, you write, okay. So in this case, ideally I can write interrupted exception, comma, arithmetic exception. It means that my function is capable of generating. It means that my function is capable of generating two types of exception, interrupted and arithmetic, and it is not going to handle both of them. But mind you, for interrupted, you must include it throws. Otherwise, it will not be compiled. It will generate compile time error. And for arithmetic exception, you may not include. So this is something about throws. We'll go back to the PPT. See, it can be used with a method declaration next to method declaration, which may have some runtime error. If a method is capable of generating checked exception and not handling it, then such method must include the exception in the throws list. See, for main, if it is not handling IO exception is a check type of exception. So we must specify here IO exception. Now, finally block of code. Now, what is finally block of code? Please consider this. Now, okay. We'll see this example. Now, in this example, take care. Suppose, okay, we have not specified arithmetic exception. Now, suppose here after result, my function returns, or due to any problem. Now, and we have something like this. Now, this hello code is after catch block. So it goes like this. If there is exception in try block, catch is able to handle the exception, program execution continues, hello will be the output. If there is exception in the try block, catch cannot handle it, then hello will not be in the output. Or if a method returns abnormally, normally or abnormally, before this SOP hello, before this system.out.println hello, this hello will not be in the output. Now, suppose if there is a need for me to compulsory execute this code before my function returns normally or abnormally, then I put such code into finally block. So what is finally block? Finally block is a piece of code that executes compulsorily before method returns successfully or unsuccessfully. That is, exception is generated or not generated, and if generated, handle or not handle. So this is the significance of finally block. Normally finally block contains resource releasing code ideally, because if a method is returning the control back, then all the resources held by the method should be released, irrespective whether the method is terminating successfully or unsuccessfully. Finally block contains code that must be executed before method returns. It includes the code which executes irrespective of error in any block. A try block will have a catch block, or a try block can directly have finally block. So we can have a try, catch, finally, or we can have try, catch, or we can have try, finally. So these are the 5 keywords that plays very important role in exception handling. For in detail study, you can refer Herbert Schill by complete reference, Herbert Schill complete reference, for detailed analysis of these keywords. And thank you all.